Hello, everybody. Hi, everybody. My name is Massimo Banzi, and I'm the co-founder of Arduino. With me today, it's Luca Cipriani.
CIO Arduino.
So today we're going to talk very briefly about Arduino, and then we're going to delve a little bit deeper into some of the work that we are doing to apply Arduino to a slightly more industrial IoT context. And the key component of this work is our Create platform, which is slowly adding more pieces. Luca is responsible for developing, managing, growing the Create platform, and maybe I will switch over to our presentation. So let's talk for a second about Arduino. One of the interesting things about Arduino is that it started off for us as an academic project for design students, and then it became essentially a tool for a lot of people. I'm going to show you a very quick video of this. This video that you see here, it's me in a taxi in Barcelona. I got on this taxi, and the taxi driver asked me if I was the founder of Arduino. And then he started to tell me this story of him building a hardware product. And he showed me that he had this Arduino book, and he was watching Arduino videos on his mobile phone while waiting for clients. So what really struck me about that is that we worked on a tool that was basically designed to make it simple for people to understand electronics, even for people that don't have a background in electronics. And what ended up happening is that all sorts of people started to innovate with hardware, to the point that I was very surprised to see that there was a taxi driver in the middle of Barcelona that knew what Arduino was making a hardware product, and was learning online and was using Arduino to do that. So this is part of essentially this big community that we call makers, who are actually doing a lot with technology, although a lot of them might not have a background in technology. So they basically do a lot of project-based work, they do tinkering, they remix existing technology, and they are an interesting and diverse community, which is a little bit different than the classic hardware sort of engineering community. So in a way, the work that we tried to do with Arduino was not to try to provide a new tool to the engineers who already know what they're doing, but it was to try to create a tool that would be useful for people that don't have a background in electronics, in software. So the main component, the main physical component of this thing was this little computer, Arduino, that we created. And the idea was enabling anybody to create by making complex technology simple to use. The idea is that throughout the history of technology, we took very complex technologies and made them simple for people. And then as we made them simple for people to use, they became extremely creative. Now, all sorts of people started to use computers to create, to invent things, because technology has made progressively simpler to use. So this particular model that we try to apply to all the technologies, to the point that even children, are learning how to use Arduino in order to do electronics. This guy here, it's a child that I met in California, and when he was like 10 years old, he did a Kickstarter for a smartwatch he developed himself based on Arduino. So in a way, for us, it was very interesting to see how even children are using this technology to learn about hardware. And a lot of people started to develop projects using the Arduino technology. So this, for example, it's a glove that can interpret hand gestures and translate them into sounds. So people that cannot speak can use their hands to generate sounds. This is a self-tying shoes that somebody developed, like, Back to the Future, the movie. Somebody else developed this thing. It's a piece of luggage that follows you around based on the Bluetooth signal from your phone. So it's a robotic bag that follows you around, based on Bluetooth. And I think that's, again, it's very interesting that somebody is able to have an idea and apply it so quickly. And also people use it to do things like this. This is it's a distillery to make all sorts of spirits directly at home. This is a distillery that somebody built, and all the documentation is online. So one other interesting feature of makers is that every time they build something, they tend to share that online. And also Arduino became an ingredient for other types of products, like, for example, 3D printers. So a number of 3D printers are using Arduino boards as their motherboard, or they derive their motherboard from Arduino. Because, again, one of the big features of Arduino that made it successful is that we made it open source software and hardware. So people can use hardware, can use our hardware design as a springboard for their own designs. So there's a bunch of people, for example, who built drones of every kind using Arduino as a starting point. So now we have a new challenge. 12 years ago, when I started working on Arduino with my friends David Quartielles, David Mellis, Tom Igo, our problem was, how do we make it simpler for people to use microcontrollers? So back then, connectivity was still something way too complicated for a small microcontroller, and was complicated for us to explain to people. So we made it simpler for people to use microcontrollers. And as you can see, in the example that I was showing, which is just a selection of 4 projects over thousands of projects that people have made in the last 10, 12 years, now we have a new challenge. The challenge is, right now there are a huge amount of opportunities in the world of Internet of Things, specifically also the industrial application of IoT. But these technologies are still complicated to understand. So we are trying to see how to apply the Arduino model successfully to the creation and the design of connected devices. So the new challenge is to basically figure out how you can make it simpler for people to apply this technology in industrial IoT. It's called, in the US, in Europe, it's called Industry 4.0, because it's the name that was originally given in Germany to this kind of application of connected technologies to the industry. And actually, we have a situation where a number of countries in Europe are also actually putting money on the table for the implementation of these technologies. So at the moment, companies are trying to figure out how to take advantage of this. So the Industrial Internet of Things, IoT, or Industry 4.0, promise a massive change and efficiency. So here is a slide from GE that shows that, there are billions of dollars to be saved just by improving by 1% the way these different industries operate. But there is a perception between a number of people who are involved in this world that these technologies are designed better for larger companies. And the issue is always, but small and medium companies, how do they apply this technology? Because it's not so easy. They don't have that much money. They don't have the people. So we will see some of the issues, And also there is this thing that we've gone through a phase of hype where the idea that I put a chip into something, this is a Tumblr called We Put a Chip in It, that lists a number of connected devices that were defined to be cool just because they put a chip inside something. And so the problem is that to go through the hype and beyond the hype of more consumer-oriented products that often don't really provide the value they say they do, while really applying this technology to a more industrial context, to us seems to have a much bigger multiplying effect on people's lives, jobs, staying competitive, modernizing the way we work. So there's a lot of things that kind of go involved in this transformation. So the world where we live in, for example, to give you a European perspective, For example, a country like Italy with 60 million people has roughly 400,000 manufacturing companies. While a country like Germany, which has 20 million people more, only has about 200,000. So clearly you can see that some countries have like medium to large companies, while countries like Italy have small to medium companies. So you can see that there are parts of the world where applying this kind of technology is going to be challenging because the manufacturing companies are most likely going to be made of like 5 people maybe, and that's going to be tricky. Also, there was a study made last year by Boston Consulting Group asking people, managers, how they felt, what they felt were the challenges, And the challenges of implementing this kind of technology was defining a strategy, changing the company culture and the way of thinking, and hiring talent. So these are 3 of the bigger areas where people felt there was an issue in implementing this technology. And we feel that the Arduino recipe, what we did for microcontroller could be applied to this kind of technology successfully. First of all, because the technology landscape is complex. This is a slide that the people who work for this investment fund in New York have been building this slide for the past 3 years. And 3 years ago, it was essentially almost half the size. And now it's like twice as big. There's like a ton of icons. Each icon is a company, a platform, a product, a technology, a protocol. So it is difficult to imagine that somebody that doesn't have a lot of money and time to do R&D can actually understand this whole landscape and pick and choose the technologies. There's also this feeling that people, you need to, in order to make a successful project, you almost need to become an expert at everything before you can even turn on a lamp, which is, kind of the challenge when we had with Arduino at the beginning, that in order to blink an LED, certain, silicon vendors, they had documentation where the code was insanely complex just to turn on an LED. So this kind of recurring theme comes back. So current IoT platforms are usually way too complex to master for most people. You need to be an expert. You need to have a lot of understanding on different technologies in order to apply this. And we cannot expect everybody to understand this. So how do we try to fix this? So Arduino, for example, has always been very interested in the user experience. So the user interfaces, the ease of use. How do you get going faster using technology? How do you, in a way, make it simpler for people to do things? So that's one thing that we try to apply. The other thing is that we have an interest in edge computing. Some of the issues that people have by using only cloud services is, what happens to my data, who owns it? So in a way, also applying this technology to edge computing, to computing that's powerful, but it's close to where you are, it's also an interesting aspect that people seems to resonate with. And also clearly, we support open source. So clearly the most open source software hardware protocols that you apply, the more people feel they are not locked into a specific solution. So obviously open source hardware and software are part of our DNA, and we try to push for this as much as we can. But again, I said, the user experience for us is very important. This designer had this idea that, wrote this phrase a few years ago, that people ignore design that ignores people. And one of the things that strikes me about a lot of these online platforms is they're very complex to understand, while there are websites that people don't need any training. So one of the, have you ever heard of somebody taking a class on how to use Facebook? In a lot of companies, when somebody applies a new technology, people need extensive training because the tool they use are just way too complicated. And the same person can use Facebook incredibly efficiently because the application essentially explains itself. It's designed to be as easy to use as possible. So we introduced this concept of friction. Friction is essentially whatever inhibits people from intuitively and painlessly achieving their goal within a digital interface. So the idea is that when I'm using an interface, I have to remove anything that would make it difficult for people to understand what they're doing, to understand how to do something, and to remove all the complexity of achieving what they want. And this is a mantra that we try to constantly apply to our work. Clearly, we need interoperable and open source platforms. And also, we try to design our products as end-to-end platforms. So we design the hardware, the software, the firmware, the content, because again, in a lot of situations, we saw that people have had a hard time understanding how to combine all these elements. If they have to go around and pick and choose hardware, software, platform, and all of that separately, sometimes they get lost and they don't implement the projects they want to implement. So how do we solve this? For example, on a hardware side, we designed a whole family of modules that are essentially commercial off the shelf. They bring most of the protocols that people tend to use in connectivity, so Wi-Fi, Sigfox, LoRa, GSM. You know, we also have other protocols becoming available in the future. And you can combine these modules as much as you like to bring them next to your device. And you can program this with Arduino, so it's usually very easy to get started. And then this is basically the device that sits in the field and talks to the cloud platform. And again, open source, documented, lots of examples, easy to use, Arduino libraries everywhere. The other thing is Arduino Create. So Arduino Create is a platform that we started working on a few years ago. And it started off at the beginning just with the idea of let's take the Arduino IDE and bring it to the cloud. So that it becomes a platform where people can use a browser to develop their code, where they can share their code easily with one another. And so you can see here, there's a picture of some code for an IoT device that talks to an MQTT server. So the idea is that if you have a browser, every sketch that you create as a URL, so you can share it with other people. We also added some feature right now where, for example, you will never see these API keys directly into the code because we hide it for you so that when you share the code, you're not sharing this secret information to other people. But the idea is we started off with this. And then we also started to say, okay, why don't we add to the Arduino sketch not only the software, but some information that people can use to document their project. So for example, this is a diagram showing the connection between an Arduino Maker 1000, which is a Wi-Fi device with a few sensors to create this project, which essentially it's a box with a bunch of environmental sensors that go to the cloud and visualize the information. And then we also tried to say, okay, let's try to support as many platforms as possible. One of the issues that some people have found is that on some platforms, adding a new type of board to your Arduino IDE means that you have to download hundreds of megabytes of software. And sometimes your computer is not powerful enough to run all these compilers efficiently. Or there are even platforms, there are certain versions of Windows where, for example, these GCC compilers might not run as fast as they could. So having everything in the cloud basically makes it very lightweight for you. You can support all the boards you want, and you don't have to install anything on your computer. The other thing is that we provide over 1,500 libraries. So if you're trying to use whatever sensor, let's say that you're using some kind of a 9-axis accelerometer, you just type the name of that sensor, it will show up here on the screen, you click on it, and you can add it to your code. And this accelerates the development immensely because almost all of the protocols, let's say MQTT, CoAP, HTTP, Modbus, both master and slave, are all supported with libraries. All the sensors and actuators are supported. Motor drivers, all sorts of devices are supported. So you just use code that's ready to go. And then we added this other feature called Project Hub, which is a place where people share their projects, and they share code, they share the bill of material, they share all the steps So for example, here on the right-hand side, you can see the Arduino cloud sensor tower that I was showing in the previous slides. So in this particular tutorial, you will find the 3D files to print the box, the connections, the hardware, the software, everything, so you can build this device. You place it in any environment, and this communicates with the cloud the air quality of that particular environment. So the idea is that when people want to build a project, they go in here, they type some keywords. Let's say, oh, I need to put some air quality monitor in my whatever offices. So I check this, I find the tower, I click, I download all the different bits and pieces. I click on the links, I go to the store, I can buy all the parts, I can assemble it, I can install it, and I can use the Arduino Create to program my devices and also to visualize my data. So here, for example, you can see that people can also give feedback. They can also derive another project from this. They can actually like the project. Here are other projects that you can find on, for example, somebody designed this smart thermostat with an LCD screen. And also we started to add this thing called the Arduino Cloud, where you can define the different properties of your devices, and you can basically have like a simple dashboard that visualize the data of your device anywhere it is. So for example, with this, you can define some properties of your device and it will generate code for you. You can load it in the device and you can have it online in seconds. And now we started to do some work, and thanks to this collaboration with Intel, we started to work on using IoT gateways like the were Arduino boards. So one of the big interesting things is that now you have these Intel boards, like this up square board that we used for this project, which is running on an insanely powerful Intel processor running Linux. So you have this incredibly powerful device that's sitting in a field somewhere. One of the things that were really, really cool is to be able to set up this device very quickly, manage it remotely using a web interface, write some code in Arduino and deploy it to the device, and being able to communicate and manage this device remotely. This will allow you to basically control remotely a bunch of these powerful boxes sitting anywhere in the world where you have them. And this is exactly the work that we did for the past few months with Intel. They helped us and they enabled us to add this feature and make it available to everybody. We're going to show you a quick video of using the Up2 board. I think one of the main features that we added, thanks to the assistance of Intel, is the fact that now somebody can set up a device like this in seconds without having to download operating systems from the network, following a bunch of crazy instructions. They just plug a cable into the device, they follow some instructions on the screen, and they have it set up. And in just 3 minutes, they have a device that's programmed, set up, working, connected to the cloud. So we're going to show you this quick video. I'm going to comment quickly what's happening here. So this is the main screen of Create. You go to Getting Started. You select the up square board powered by Intel. It shows you where to plug all the cables. Then you essentially upload these bits of software called the Arduino connector. And after a few seconds, the device is set up. You can give a name to it. And essentially, by pressing a button, you find yourself in the Arduino IDE in the cloud. And if you see at the top, it says vibration detector via cloud. What this means is that our IoT gateway is set up somewhere on the network. We can communicate with it, and we can actually deploy code remotely. So the example that we're going to show you now is that we took a 9-axis accelerometer, gyroscope, 9-axis motion sensor, and we created some code that can detect vibrations. It can report back the vibrations. So you can, for example, place this device next to an industrial machine, put the sensor on the machine and you can measure the vibration. And if there are some changes in patterns, you can actually use the cloud to communicate that something is happening. And this is basically using Arduino code, the one that you would run on an Arduino Uno, compiles and becomes a Linux application that runs on your device. Here you can see the up square board and this 9-axis sensor connected to the I2C bus. So we are using classic Arduino code. We are taking advantage of the MRA library from Intel. We're taking advantage of a bunch of other libraries from Intel. And you can see from this screen that you can actually run multiple Arduino programs on the same device. So since this device is so powerful, you can actually run a bunch of different Arduino programs in parallel on your device. So if you have knowledge of Arduino, you can apply it to these gateways now. You can build a complex application on these type of gateways using your Arduino knowledge and some of the powerful libraries that Intel has made available. If you look at the website, there are examples on using OpenCV to detect people, or even more complex libraries to do machine learning, all accessible through Arduino Create on these Intel platforms. Let me show you just a few other projects that are available that people have shared. So, for example, this is it's a tracker. It's a device tracker that uses the Sigfox protocol, and when it detects a vibration, it starts to send a message via the network. This is something that you can go to Project App, take, and implement. Somebody else built an online attendance systems for a school that's based on the Arduino Create Cloud and all of that. Somebody built a pool controller that again uses the cloud and Create. Or somebody built these gas leak sensors, again, based on Create, the cloud, and all of that. So just to summarize, let me just stop the sharing and go back to the camera for a second. Sorry if some of you have been able to view the video. You can actually try these things right now. If you register for Arduino Create, which is free, you can see all of these features right now directly in your browser, so you don't really need to view the video I had in my presentation. But the general idea is, and then we'll open to questions. So the idea is, we have done some work to basically try to remove the obstacles across the chain. So we have these maker boards that are very easy to program from the Cloud IDE. We now have a platform for edge computing, for edge computing based on Intel that you can program to Arduino. You can run multiple sketches, you can have multiple gateways, you can have multiple sketches talking to multiple maker board in the field, and then you can bring everything to Arduino Cloud. So this is just one of the first steps that we are doing to provide tools that make it super simple for people to build complex applications. So at the moment, essentially, we worked on bringing all of this data and the devices connected to the cloud. In the next few months, you will see more and more features that allow you to visualize the data, process the data, and all of that.
Okay, maybe we can just start replying to some of those questions. So one of you is asking if the architecture is scalable. It is scalable now in a sense that is possible to have as many users as we want. We are also working on having teams, so eventually you can create your own team and have your own private application. Now every application that is on Arduino Create is a public application because everything is free, but we are also working on having a private application, obviously, for enterprises. So this is the goal for commercial purpose use case. Then there was another question about collaboration. So as of now, you can just share the link of your code, and that will enabling directly anyone else on the web to just copy the link, go in, clone your sketch, and keep working on it. So this is a super easy way to start collaborating. As soon as we will deploy and it's already under testing, a way to add other person in the same team, this will allow companies to have dedicated team on every single project. About the fact that the software is open source, yes, the connector is open source. It's already under the Arduino organization on GitHub. So if you look for Arduino/Arduino-connector, you can see the source code. The backend is not, but obviously it's a software as a service, and it's a public API. So if you want to build something on top of it, you are completely free of doing that.
So there's a question about GitHub integration. So in the roadmap, we plan to let people be able to synchronize with GitHub. At the moment, it was probably a bit overkill for most of the use cases that we were investing on. But we found a big interest from enterprises in having GitHub integration. So more in general, more than just GitHub integration, I would say we are working on Git integration. So much more generic, let's say. So there's a question about third-party extension in Create, like the ESP8266. So the idea is that we, at the moment, Create is free. And it's available to basically all the platforms that correspond to products that Arduino sell. So it is free for products that Arduino sell. It is technically possible to support all of the other platforms. The only thing is that you have to understand is that running an infrastructure like this is a very expensive thing. We're running on top of Amazon, and although Amazon is helping us, it's very expensive. So at the moment, we made the choice to make it free for people to use Arduino platforms or Intel platforms. In the futures, we will start to charge money for Create. For all the use cases where people basically want to use technologies that Arduino basically makes no money from. So you will be able to program every type of microcontroller you can think of with Arduino. But obviously there will be a monthly charge. At the moment, the cost of this monthly charges is not yet public. We will make it public most likely by the end of the year. At the moment, it's free and you can use it. You can use it freely. When we start, we will implement two features. One is the ability to keep all your sketches completely private, and the second feature is to basically being able to use whatever platforms. So in that particular situation, there will be a charge. It's a little bit like GitHub. GitHub is free if everything you do is open source, and if you start to want to have private repositories, you have to pay. So that's going to be like a similar model for
and for the cloud data, instead, it will be more based on the amount of data you are going to send to our cloud, obviously. And if you are also using our own product, you will have more discount. So this is enabling small company to start very lean and quickly. And eventually, if they scale massively, they can directly have access to our API and have their solution on top of our own.
So there's a question about commercial examples. So one of the things that's happening is that right now we are working on a number of pilot projects with companies, and there's a bunch of companies who are using Arduino in their daily life in general. The problem is that normally when people build a commercial application, they tend not to want to share their information. So for example, I don't know, a few years ago, there was a job, was a job advertised on the Apple website, and they were looking for somebody with Arduino experience. And I know for a fact that they use Arduino to prototype things or to build things. And but clearly they never talk about this publicly. And there is always this strange thing that once it becomes like a commercial application, either they don't want to talk about it, or they prefer not to talk about it, because usually when somebody builds an industrial application, a commercial application, they don't want to reveal in general what kind of technologies they are using to build the application. So we are working with a few partners to be able to start advertising better that they use our technology in their product. So I guess one of the first ones that we will discuss is that we are working with a company that builds sensors for agriculture. They are using our product, and as soon as we are ready, we will go out and document what they're doing. So they are using our maker boards and the Sigfox connectivity to be able to do low power sensors in a field, battery power that run for a year without supervision.
The other thing is also that we don't inspect the code of our users.
Yes.
So usually there is also, a privacy thing. So the user are able to create their code on our own cloud, deploy it, and eventually likely cancel every code they have on our cloud. And we don't really care. I mean, it's your code. You can deploy it wherever you want. And now we support all the Intel-based platform if they are running Linux. So if there is a Linux operating system on top of an Intel IoT gateway, then your commercial application can work out of it. And we absolutely cannot really know how many applications are already being built on top of it. So some of them are shared, as said, on Project Hub, but we know that many other companies are creating products on top of it, but they don't want to share it.
So there's a question about examples with Microsoft Windows 10 IoT Core OS. So if you go to create.arduino.cc Project Hub and you look for Windows 10 IoT, you will find some examples of people using that technology with Arduino. And we technically support creating code that compiles as a Windows 10 IoT application. But at the moment, I have to say that that particular collaboration with Microsoft is stopped. And we don't know exactly what is Microsoft's strategy about Windows 10 IoT Core. So, as long as it works, it works. But we don't know exactly what Microsoft is planning to do or who is actually using it for products. Yeah, I guess we can share the presentation mostly as a PDF. We'll put it on our website somewhere. What kind of integration? Well, so there was a question about Android. So right now we don't support Android as a target operating system. We haven't worked on that yet. It is possible to connect Android and Arduino. Actually, the Android accessory development kit from Google is based on Arduino. It's actually the latest version they published, which is still now a few years old, is based on the Arduino Due. So technically, there are a number of products that are based on having some kind of Android phone or tablet as the UI, talking over USB to an Arduino Due or an Arduino ADK, which is another type of Arduino. And that particular Arduino controls all the IOs and all the other sort of, there's a number of examples online of people doing that. And I know about a company, which I cannot mention, unfortunately, who builds some kind of gym equipment where the interface is Android, and then they have sort of an Arduino-derived piece of hardware in the gym equipment that drives motors and sensors and all that. One question was about the collaboration capability. I think Luca explained that before. Can Arduino platforms be used in industry use cases? Yes. So there's a number of companies. For example, there's a company called Industrial Shields that sells effectively what are PLCs based on Arduino. There is an Arduino board inside. They integrate with their own hardware and they sell it in a box where you can interface directly on the field. And that's based directly on Arduino hardware. And it's used a lot in Europe by people building lightweight industrial automation. There are platforms like Industrino, which is basically an industrial hardware that's derived from Arduino. Siemens created this thing called the IoT 2020, which is essentially an IoT gateway based actually on the old Intel Galileo, and that one is used and it's programmable with Arduino. And some people are using it as an IoT gateway, but actually a bunch of people are using it directly as a controller for industrial applications. But there is more and more, and there's a bunch of other companies that are building sort of Arduino.
Someone else is also asking if there is an email to contact. Yeah, you can write to support@arduino.cc and directly mention Arduino Create Intel IoT DevFest, and you will get an answer.
So the question was about using Arduino for commercial purpose. Technically, so the Arduino code is open source. We use a license that says basically if you don't, if your code is your code, so you don't have to make it open source. You have to make open source only if you change the Arduino code itself, so the Arduino libraries itself. You need to make that changes available, but your code is your code, so you can use it in a commercial product. You can even buy Arduino boards, program them with your hardware and resell them, as long as you don't say that what you're selling is an Arduino product. You can put an Arduino board in in whatever you want. And there's actually people who have bought Arduino boards in quantity to place inside products they were selling to other people. Again, there's a few companies who have done that. I can't really say who they are because, unfortunately, again, we see the orders on our ordering system of some large company who buy a bunch of Arduino boards, but we can't really say because we are not authorized. There is a board called Arduino Industrial 101, but that's kind of it was not designed by us directly. It was designed by another company, and they called it Industrial 101, but that's not exactly an industrial platform. They use that term, but it's not exactly industrial.
If you want to look at all our mega boards, they are all listed in our main store on store.arduino.cc. There is a full list of boards and all their characteristics. So there is each of them for every kind of connectivity.
So if you have the chance, go to create.arduino.cc, register, and you will be able to see all these features in action. So Arduino Cloud is essentially a part of Create, which we are slowly releasing. The one that you see right now on the website is a prototype that we designed for people to be able to just try out like a very, very, very early version of the product. At the moment, that particular product is based on MQTT, so it's using our own MQTT server, which is not super scalable. In the next few months, we are going to be migrating to a different backend. The version of Create that we described today, so the ability to remotely program an Intel gateway and all of that, it's actually based on the Amazon AWS IoT, so it is super robust, super scalable, supports any number of devices. And
it is using as well MQTT, so it's the main protocol. We are also investigating and investing and supporting many other protocols, the most popular ones, obviously. So, co-op, REST, APIs, and so forth.
So there's a question about educational use of Arduino. So in the past, we have successfully partnered with a bunch of foundations to bring Arduino to the classroom. So, for example, in Spain, through the Telefonica Foundation and a number of local banks, we created this project that now we are applying worldwide, which is called CTC, Creative Technologies for the Classroom. And it is a program which basically starts from teaching programming, then Arduino, then robotics, and then the students build their own projects. And it also includes in the package, it's also included the part where we train the teachers, because we realize that around the world, in almost any country, the governments don't really invest money in training teachers, and teachers sometimes, they don't feel like teaching something they don't understand very well. So we do that. And this particular program has been implemented with over 15,000 students in Spain. And most of that was paid by foundations. Otherwise, this CTC program is available to purchase. So some schools are just buying the box. The cost of the box contains all of the teacher training, all of the educational materials, contains sensors, Arduinos, laser cut, 3D printed parts, plastic parts. So there's everything to teach 20 students. And also there is access to an online e-learning platform that both the teachers and the students can use to learn about programming, Arduino, robotics, and all the rest. So the model depends. In some countries, some foundation put money. In some other places, the parents, collect $50 each, whatever, and they buy a box that inside the box there's a key that unlocks all the contents online and the e-learning platform. So it's called CTC. If you go to the, let's see.
It's create.arduino.cc/CTC, but also on our main website on arduino.cc, there is a specific page telling about that.
So you can see here, it's create.arduino.cc/CTC. And here there's some explanation of what CTC does. And there's also an email that you can use to write. Otherwise, if you go to the Arduino website, www.arduino.cc, there is a link called Arduino Education. And there's an explanation of all the activities we do in education, including the CTC. So it's under Learning, Education, and you get to this page here. It's not exactly, so the product that we are using, so this kit is based currently on the Arduino 101, which is using a Curie processor. So right now, the Arduino 101 is available. We are continuing the manufacturing, so the product is not discontinued. So there is a difference between Intel directly manufacturing the Arduino 101 and the longer-term availability of Curie. So these are two different stories. So for the time being, we are manufacturing the product with 101 and supporting it. Should in the future this processor no longer be available, we have other boards that can take over from the Arduino 101. So from the point of view of the person who is teaching or learning, there's not going to be, we are going to always provide something that works. So it's not a big problem.
Oh yeah, we can also meet at the Maker Faire in Rome.
Yes, if any of you is coming to Maker Faire Rome, which is from December 1st to December 3rd in Rome, we will have demos of all of these things. You can talk to all of us. We're over there. So if you get the chance, come over. So thank you very much. And, I'm glad a lot of you enjoyed this session, and talk to you soon.
Thank you.
Ciao.
Bye-bye.
Bye-bye.